All right. Good morning, everybody. As you can see today, we got a little project here on the bench. If you haven't heard yet, the legendary Maxi Trax from NAPA is back at NAPA. It is now under the NAPA name, not the Maxi Trax name, but this is the same compressor. It's $149. You can get it, typically you can find a 20% off coupon, get it for about $115 on NAPA. 10 CFM twin head compressor. Very popular. You may notice this is very similar, if not exactly the same, as a bunch of the other high-end compressors you see on the market. Seems like the fun thing to do is to take one of these compressors and slap a Flate name on it and make it your own. So today we are going to make the NAPA Flate. I'm going to show you how to turn this compressor into probably what I would consider the best twin 10.5 CFM compressor out there. Do a couple simple modifications. This is going to be a two-part series though. Today we're going to do kind of the simple stuff, a couple of little items to make this better, things that most people are going to do when they get this compressor. Part two of this, we're going to tear it down and address a couple of the what I see as flaws in this. Namely, the one that bugs me the most is the egregiously undersized wires that are supplied to this. This is a 90 amp motor. Should be supplied with about 4-gauge wire. These are 8-gauge at best. Very undersized for what this is. So part two, we're going to address that, and it's going to be a pretty in-depth as we kind of re-engineer this a little bit. But today we're going to do step one. The two biggest complaints people have with these are the non-standard air chuck here. The other thing they don't like is that it's an open system. We turn it on, this just blows all the time. The thing we want to do today, we want to convert this to a closed system, so it has your same typical valve on it that you'd see on your normal compressor. You can use all your normal compressor accessories with it. So we're going to change that out. And number two, we're going to put a pressure switch in this. This currently doesn't have any kind of pressure switch. So when you turn it on, it runs all the time. That's the reason it's an open system, so that it can just blow air all the time until you hook it up to your tire, take it off, stays blowing air, open all the time. We're going to convert that to a closed system, and to do that, we got to put a pressure switch in it. So that's going to be today's video. I'm going to tear this down, show you how I'm going to do it, and hopefully you guys enjoy this one and learn a little bit along the way. All right, step one on this, we just got to get this cover off. There's 4 screws going down into the case around here, and then there's these 2 screws here that are holding this plastic case half together. That's where all the electronics are for this. So the first thing we're going to do is just tear this down, get this separated, and I'll show you what's inside. All right, we got the cover off. I left the backside on here because it kind of holds everything in place here. I'm going to reposition the camera and get in here. Nice tight shot for you so we can show what I'm talking about and what our next step is here. Okay, I think I've got the camera positioned about as best as I can here to show you what's going on in here. You'll see back here there's a set of wires. Those are coming from our leads. They have the alligator clips on them from the battery. They come in here. One side comes right here to this glob of solder right here. It's just joining the battery lead to this main power cable that's going down. That's our positive to our battery. This switches the ground side of the battery, so we'll get to that. But power comes in here, goes through this junction right here, runs down to the inner works of the motor here to the positive terminal for the motor. This smaller wire that you see coming up here, this is coming from the thermal protection. If this motor has thermal protection, it's got a switch in there. Gets too hot, opens the contacts, shuts power off to this lead. You'll see this lead comes over here, joins our circuit board. I'm just going to kind of slide this out a little bit. Can't really see, but then from this lead, you can trace right on top here. You can trace all the way around this lead. This hot lead coming in here runs around to this little spot right here. See right here in the back, this little guy right here. That is, if you look on the underside, These wires right here come out of that, and they run over to our switch. So hot runs out to the switch, runs back in here, runs through our circuitry here. I wish I could tell you I knew what all that circuitry does. Maybe somebody smarter than me can chime in and tell you what all this circuitry does. But runs through this, and then you'll see right here you've got two relays. So what this does is your ground comes up from the negative side of your motor, comes up here, joins our circuit board right here. Best I can tell, you see two relays here. Best I can tell, they run in parallel just for a bit of redundancy, I'm guessing. And then comes here, comes together, and then right here, this big glob of solder you see is the negative lead that goes to the negative side of our battery. So, like I said, I wish I could tell you what all this circuitry does. I'm guessing it has something to do with kind of a soft start so that it doesn't spike the amperage up real high when you first turn the motor on due to the egregiously undersized leads that it has there. I'm guessing that's what it is. Try to soften the start of the motor a little bit, clean up the power a little bit. Anyway, we're not going to mess with this today. We are going to mess with this in the future. Come back for version 2 or part 2 of this. We're going to slide this back in its little holder here so it keeps out of the way. What we're concerned with today is going to be right here. This is that power lead I told you that's coming from the thermal protection. So we got main power coming in here to the motor, goes down, comes off of that thermal protection circuit, comes back up here and plugs into our circuit board. What we're going to do, step 1, to make this into a better compressor is we're going to add one of these little guys. If you haven't seen these, this is just a pressure switch. So all it does is we're going to mount it up into our manifold here. This is where you can see coming across the heads, and then on the back side here is where the air hose comes out. So this is our manifold where the pressure is built, where the air is brought together and sent out. So we're going to take this little guy and we're going to mount him up in there, and you can see we've got 2 leads on the bottom, and all this is a switch. Simple as that. It turns on when your pressure gets to 70 psi, turns off when your pressure gets to 100 psi. And you can see that, let's see. Sorry, this is an 85-100. I thought I got a 70, but I got 85-100. So turns off at 100, turns on at 85. And you see that listed on here. So what that's going to do is when there's less than 85 pounds in this, and kick the motor on, pump it up. Once there gets to be 100 pounds in our system, going to shut it off. Now this is a 150 psi max compressor, but I can't conceive in any situation that I'm going to be using this for that I'm going to need 150 psi. Can't see any situation I'm going to need more than 100 psi out of this thing. Really, I could probably get away with an 85 for the top number, but we're going to put in this 85-100 to save us a little bit of wear and tear on the compressor. It doesn't always have to pump up to 150 psi. It'll shut off at 100. But my plan is to take this little guy. We got kind of a spot right here that'll fit around everything. We're going to drill and tap this manifold right here, screw this guy up into the bottom, and he's going to live right in here to kind of give you an idea. And then all we'll have to do with this is take this lead right here that powers our switch on our circuit board. We already traced that out, know it goes straight from here over to our switch. So we're just going to take this, plug it on one side, and we're going to take a piece of wire, make ourselves a jumper that goes from this side of the switch back over and plugs in right here on the circuit board. So all we're doing is interrupting this switch right here. And there's actually enough wire. You could, if you wanted to, you could actually just cut and put ends on this and make this little piece of wire work. But I'd be concerned about if your switch goes bad and you ever needed to bypass it for some reason, making sure you kept a long enough lead here that you could go from where your pressure switch is mounted back over here to the circuit board. So if you ever, like I say, if you ever did have something go wrong with that, you could bypass it. So that's the goal for right now. The other thing we're going to do, kind of spin this around a little bit for you. See our switch here. For right now, that switch is going to stay. But our hose comes out up here, and it's just drilled and tapped into the manifold here. While we have this apart, we're going to take this hose off. I'm pretty sure this is an 1/8 inch NPT fitting. I'm going to punch that out to a 1/4 inch. I'm going to drill it out, retap it to a 1/4 inch NPT so that I can screw a standard lead into it, a standard hose lead into it, and not have it neck down to that eighth inch NPT fitting there. So we're going to open that up. Our air fitting here, or our pressure switch, is an 1/8 NPT, national pipe thread, nominal pipe thread, whatever NPT stands for, 1/8. So I do have an 1/8 NPT tap and a 1/4 NPT tap. So while we have this apart, we're going to pull this out, punch it out to 1/4, put in a different lead, and drill for our pressure switch. Okay, I got you flipped back around here. We're going to pull this head off. The easiest way to pull this out, get it out, and drill and tap, what we got to do is pull this off. So I'm just going to pull both these heads off and pull the whole assembly off. Got lucky and nailed the T-handle on the first one. The markings are pretty much useless on this old T-handle, but it is a 3mm Allen key, if you're wondering. We're going to spin these out real quick with the T-handle. All right, I do want to say something about the bolts here. I did notice that most of them were so tight, I was afraid I was going to break something. I really had to crank on them to get them to pop. But a couple of them were almost loose. So I might suggest, if you get one of these compressors right off the bat, to just grab a Allen wrench and double check the torque on your head bolts there. Make sure they're all torqued down. And I did forget, I got to take the other side of my plastic off because it's kind of holding on to things here. Okay, our head's loose on there. I do need to get a wrench, and I'm going to take this hose out now so that I don't have to muck around with pulling this whole thing off and out of the way. Had to go dig around for a wrench. I'll give you one guess as to what size that was. Yes, it was 10mm. All right, I wanted to pop in here real quick and show you. Here's the hose we took out. Here's our, I know this is an 1/8 NPT thread. Here's our hose. The thread pitch does not match. So this is definitely a metric thread here. I don't have any metric thread gear in the shop, any hoses or anything. So I'm definitely gonna have to punch this out to a 1/4 NPT pipe thread. I was planning on doing that anyway. Got a tap for it, no problem. Anyway, moving on. I kind of forgot. There's a part I didn't address. I kind of skipped it before I got tearing into it here, so I kind of set everything back together. My plan for my pressure switch is basically right in here, in amongst these wires. We're in the way right here. You can see in here, but you can see here, one of these screw bosses is right where I want my pressure switch to be. So what I'm going to do, I'm just going to eliminate, you can cut this off with a Dremel or sharp knife or something on both sides. We are going to lose one of the screws here. But one thing I did notice when this is apart is right here and right here is another set of screw bosses that are already molded into the plastic. All I need to do, you can actually see it's got the hole and everything. All I'm going to do is just punch that out with a drill bit, and I'll be able to put a screw on the outside here, right here, that'll screw the top together so that I won't lose the clamping ability here. Not critical. There are some clips that hold the top together, but I think I just like the finished version of that a little better. But the most important step I kind of forgot is I kind of forgot to mark where I want this pressure switch to live. And if I want it to live kind of in here in an okay spot for all the wiring and everything, it's got to be about right there. I got enough room. I got some space between the circuit board, so I don't have to worry about it hitting there. It's in between the circuit board and the wiring. So I'm just going to take a good old Sharpie, and I'm just going to mark that spot on the side of our manifold there. So when I get over, I'll know I got a drill right there. Now we can take this apart. I already pulled all the bolts out and lifted this off once before I realized my mistake and brought you back. So I'm just going to pull these screws back out here. I just started those in place so that I had everything tight in there. Now we got it apart, and you can just lift this off. You've got the plates here. You can see the reed valves. They're covered in some really funky, nasty grease. We'll probably leave that because I don't want to mess too much with that. But pull the bolts out, no problem. They're just sitting here on the bench. And then we'll show you the underside of this. Again, tons of grease in here. I'm probably going to take some degreaser and degrease this side because I am going to be drilling and tapping here, putting some chips into this manifold. I want to make sure I can get them all out of there so they don't get spread into the motor later. But now what we're going to do is we're just going to take this over to the drill press. You can see I've got my mark here for where I want that. I'm going to center it up, drill, and tap an 1/8 NPT hole there. And you can see on this side, this is where our hole for our hose is. We're going to drill that out and tap it to a quarter 20 NPT, or not quarter 20, quarter NPT thread. That's the next step. So we'll move on to that. Bring you along. Okay, everybody, over here at the drill press, got a bit chucked up here. So this is for the 1/8 inch that we're going to put in the bottom for the pressure switch. If you look up on a drill guide about what size drill bit for an 1/8 inch NPT, it recommends a Q bit. I happen to have a Q bit in an old drill index that I have. So I've got the Q bit chucked up in there. You can go one size up from that, which is, I believe, 21/64, and one size down, which is 11/32, I believe. I'm going to have to double check that. Don't quote me on that. But if you look up 1/8 inch NPT drill index, you can see what size it is. So you can see right here, I've kind of got marked out where I want that bit to be. Got a set of calipers here. This is about a 3/4 inch wide block. So I set these calipers to just about half that. And I'm just going to use these. I know this is not the best use of a set of calipers, but I'm just going to use these set of calipers to scribe myself a line in there that approximates the center. You want to leave it set just one side or the other, either a little bit wider, a little bit narrower than what half would be. And you get two lines that are nice close together, and then you go right in the middle of them. And I'm just going to take a center punch here. I'm going to line up with my mark where I want it to be. And I got my scribe marks to give me center. I'm just going to take a ratcheting center punch, give it a couple of hammers there, and now I got a nice center point there that I can line up under my bit. Now, because I've got the ends, the heads for the pump on there, I am going to use a piece of 2x4 here to bring this up, space this up so these aren't sitting on the deck of my drill press on my table. And I am making sure that I'm holding this square now down nice and solid to the table so that I get a nice straight hole into this. And as you're doing this, you got to remember you're not going all the way through here. You're just drilling down into it. So I'm gonna drill a little bit and look, drill a little bit and look until we get to the proper depth. Okay, so we punched through, left a little bit of chips in there. Now I'm going to take my compressed air and blow that out. But before I move on to that, I am going to drill out this hole for my quarter 20. I said it again. Somebody's going to have to count and say how many times I said quarter 20 when I meant quarter NPT. For my quarter NPT fitting that's going in here, so I'm going to switch out this bit. It's a 7/16 size. I do know that for a quarter NPT fitting. So I switched this out to a 7/16, and we're going to punch that hole out while we're at it. Okay, went over, I grabbed my little machinist vise thing, little cheap vise that I set on my drill press every once in a while. Just set it here on the bench. Make it a little easier for you guys to watch this. And we're now going to tap these holes. So I got the 1/8 NPT in a tap handle now, and I'm just going to tap these by hand. These aren't that critical that they're perfectly straight. So we're just going to get this started This is always the hardest part with a tap, is getting it started straight. We're going to take our time here, work it around real easy. Pop our chips. Okay, we're started in there now. And you can feel, because this is tapered, this is getting tight already as I'm screwing it down in there. So I just want to back this off. I want to see what my threads look like. See if those are down in all the way. Screw my fitting in here. Make sure it screws in. Okay, not quite screwing in, so we're going to have to tap a little bit deeper. All right, left you guys out a little bit of that, so I was doing a little bit of trial and error experimenting here. We've got that now threaded in deep enough that I'm comfortable with it. It's got deep enough threads. But to go back to the tapered tap going into a straight hole, you really need to open up the hole a little bit bigger to start with, because our threads are up in the top portion of this and going down into kind of a hollow. So it's easier to just open up that hole. So skip the Q bit. I went to a 21/64. Ran that down in there and then really worked the tap back and forth quite a bit to really get it to bite in there, cut the threads, and it's cutting up. We're halfway up our tap here, so we got a good amount of threads cut in there. But it definitely takes a little bit of patience, a little bit of work to get it done. But skip that Q bit, go one step higher, 21/64, or even one step up farther than that even, so you can open that up enough to get so that'll screw in there. But we got that one done. Now we're going to go back to switch over here to our quarter. I'm afraid I'm going to run into the same situation there, so probably going to be back and forth to drill a couple of times, but I'm going to tap this one out, and I'll let you know how that goes. All right, so learned a few things on this process here. Number one, skip the size listed for the bit and go up at least a 64th, if not a 32nd. Makes tapping easier and still going to get a good seal on this because it's tapered. You just need to get the top of these holes here expanded out a little bit, just so it's easier to tap, so you don't feel like you're going to snap your tap off. We got things drilled and tapped. I didn't take you back and forth between the drill press a couple of times and show you tapping that, but got a little dymo tape on there, or a little plumber's tape on there. Now we're going to screw these in and set them for the last time. So got our big crescent wrench here. And don't forget, with pipe threads, you definitely want to crank them down good and solid, and make sure you do use some thread sealant of some sort, whether it's pipe dope or tape, but definitely a thread sealant of some sort. Make sure you get this good and tight. But we'll spin this one in good and tight. And you can see I'm not grabbing clear out on the end of my 12-inch crescent here. I am grabbing in close so that I don't get too crazy and over tighten and strip, because we are just screwing into aluminum. But we'll get that in there good and tight. Call it good. Now, here's the other part. Got a little whip. This is about a 3-foot whip extension here. I just happened to have it in laying around, so I figured I'd repurpose it for this. But get a little dymo tape on the end of this, and flip this over. I will say, if you have access to a bottoming tap that is the 1/4 NPT, I would use it to make sure these threads get bottomed out good in there, make your life a little easier as well. I don't have one, but this is still going to work just fine. Okay, so I kind of temporarily set everything back in place here so you kind of see what we got going on. But this is, you can see where the pressure switch now sits in here, kind of in a little gap that the wiring just runs around. So now we have to take this connection off the circuit board here, plug it onto one side, and then I've got a little bit of, that looks like about 14 gauge wire, but I got a little piece of wire. I'll put female spade connector ends on a little jumper wire that'll jump from the other terminal on our switch up here to our circuit board. So that's the next part. I'm going to kind of take this back apart just a little bit so it's easier to work on, but bring you guys along. Okay, bring you guys back in real quick. On further inspection, that's actually printed on there that's 18 gauge wire. So got a little piece of 18 gauge we're going to use for our jumper, but I'll show you how I make my jumpers here. It's a method that works really well for me. Never had an issue with it. And very happy with the results, the way they turn out. So just stripping off a little bit of insulation off my little jumper here. And going to be using these little connectors. All I did, they're just your standard plastic connector, but I pulled the piece of plastic off because I hate the plastic. All it does is get in the way and cause problems anyway. So pulled that off and get this threaded into our connector here. And then this is where a good pair of crimper pliers comes in very handy. This one has a specific slot for non-insulated connectors. Crimp it down and it's crimped solid. Now take a piece of shrink tube. I'm going to find a piece of shrink tube that will go over our connector. Go next size up. So a piece of shrink tube that'll go all the way over our connector. I'm going to cut that piece of shrink tube that'll fit over the connector. I'll slide that on, make sure it fits. I'm just going to cut that in half because I don't need the piece that long. I'm going to save the other piece for the other side. And while we're doing that, I'll go ahead and crimp on my other side since I'm sliding all the way over the connector. I don't have to have it on there before I start. So we'll just crimp that down good. Now what I like to do with these is I like to insulate the whole thing. So I'm going to leave it right up there near the end of that connector so that it's insulated. I'm going to take my flame and I'm going to start heating right up there at the top where it's around the connector so that it kind of shrinks down and sticks on there first. I'm going to let that cool for a second. The reason I do that is it's kind of gluing it to the end so that as it shrinks, it doesn't pull back from the end as much. Since we got another end to do here, do the same thing on this other end. Just kind of take that, work the flame around until it starts to shrink down on the connector. And we'll go on to shrinking it the rest of the way. There we go. All right, so now we're well insulated, shrunk down on there nice. Now all we need to do is pull our connector off here. I'll tell you, you don't have to worry about that connector coming off. Make sure our insulation slid back up on. Now I left the head loose so that we could do this easy, but we're just going to fit that connector. Oh, just ran into our first snag. I'm going to hold that up there so you can see the connector onto here is smaller than the connector onto here. So I'm going to have to cut this off and put another one of these connectors on. Now these larger connectors will be okay if I ever have to rewire this, but I do have a smaller one of these connectors. I'm going to pause here, cut an end off of this, and put one of those smaller connectors on instead of the larger one. Okay, now we got our bigger connector on there, and I'm just going to lift the head up because this is easier to do this way. Shrink tube's still a little warm. And then we don't have quite enough room, I don't think. Let's see. Let's get this set in place. So this makes a little bit tighter connection than I want to see. So I'm just going to bend this connector down here. All I did is bend it over a little bit. And that's just to make sure it's not pressing hard against the bottom of the case. Make sure my wire's routed in a better place here. Didn't like how it was routed either. Push that up on there. Kind of get everything set in place. And now it's barely touching, but it's not pressing on it, so I'm not concerned about that. Now we go back to our jumper. I'm going to do the same thing here. This is one of the smaller connectors that's sized to fit this post. And this a little smaller, so we'll use a little smaller piece of shrink tube on this one. Cut it down because we don't need the whole thing. Stick there at the top first and then shrink our way down. And it stays mostly insulated. So now we're going to reach in here. That end's still hot, so we'll start with the other end. Let that cool for a second. Get that started on there. Might have to use a little pair of needle nose to get that one to go on. Okay, bring you back in here. That post fought me a lot more than it should have. So I didn't want to sit there and struggle on camera that whole time, but I did bend it a little bit, so I'll bend that connector back out. There we go. Okay, so I've got everything kind of tucked back up in here. Circuit board is tucked in its holder on here. I got the 2 screws started in here, and you can see how this pressure switch just tucks up in there. One thing I forgot to show you that I talked about is the screw boss here that is in the way. On this side, I've already cut it off. I forgot to show you that, but I'll show you. All I did was take a pair of dikes like this and just come in here on that plastic and just try not to shoot myself in the face with this. There we go. Just cut off that that screw boss right there. It does leave a little hole there, but no big deal. Then this will come up. I also, you can see I drilled this hole out here at the top that matches with this boss up here, so that when we put this together, I'll be able to run a screw through here and screw the top of this down. Now I just want to make sure I get all these wires and everything tucked back up in here far enough that they're not interfering with the case half when I put the case back up here. But this side's ready. We're done with our modifications here. I'm just going to put this back together, and I'm just going to use one of these screws that came out of these holes up here in this spot that I drilled. One thing I did forget, we still got to put our screws back into our heads here, so not complete yet, but we got to drop our screws in and get this part put back together as well. All right, and last but not least, our new screw in here. Oh, it looks like that little one may work. Yeah, feels like it's together. So, NAPA Flate, ready to go. I'm going to go get it hooked up to the Jeep, and we're going to see if this works. All right, here we are. Compressor put back together, ready to go. Hooked up to the battery on the Jeep. Got my inflator here plugged into the connector. We're going to turn this on, see what happens. That happens. Pumped right up to 100 psi inside the compressor, shut off because of our pressure switch. Now, when we give it the juice, just like it's supposed to. Kicks on, kicks off. That's what that pressure switch will do for you. And now we've also got a closed connector here. So when we disconnect, a little bit kicked on there, but shut right off again. So there you go. That's first step in taking your NAPA and making it a NAPA Flate and the best flate on the market. Hope you enjoyed that one. Catch you on the next one.